Our next speaker is Sandy Parent. Sandy is a forensic scientist in the trace evidence section of the Texas Department of Public Safety Crime Laboratory, which she joined in 1997. She graduated with a Bachelor of Science in Chemistry from Michigan State University. She's currently a member of the Scientific Working Group of Material Analysis, and she is a member of the steering committee for this symposium, the Texas Sheriff Association Cold Case Committee, and the Texas Department of Public Safety Trace Evidence Advisory Board, and she has served on the NIJ Advisory Panel. Her talk is going to be the significance of class association in automobile paint evidence.
Thank you, and thank you everybody for coming on the last day, and I know it's really early for some folks. I just want to say that Jennifer Howard is who we had as our intern, and then we were lucky enough to hire her after she graduated from Sam Houston State, and she has done a tremendous job on this study, and she has done a lot of the work. So I definitely do want to give her a lot of credit for this presentation. So the title of my talk is The Significance of Class Association in Automotive Paint Evidence, and I'm going to build on what Dr. Goodpaster spoke about as to the type of comparisons performed, as well as Dr. Marsh in regards to the occurrence of paint evidence. But I must admit, when Dr. Marsh initially started talking and saying how common paint was, I was like, what is the purpose of my talk? But then luckily in the end, as she showed that there wasn't that many pieces of actual automotive paint recovered from the clothing. Automotive paint samples often seen in trace amounts are commonly encountered in forensic laboratories. Automotive paint evidence is considered class evidence, and forensic scientists are often challenged to determine the significance of a class association. Given the wide range of analysis, which may or may not be destructive to the sample, an appropriate analytical scheme is necessary for the identification and comparisons of paints and coatings. The purpose of our study is that there is a lot to determine the variation of a sample. Consumer preferences and design trends, along with costs and environmental legislations, are all factors that are taken into consideration by the automobile industry and play into the selection of the composition of the automobile paints. Therefore, the automobile paint industry is very diverse, which enhances the significance of a paint association, but also makes determining the significance challenging. And this is a point that we will talk further about in regards to David Spence's comments about how many paint chips were recovered from clothing, but I'm going to show you how diverse the market is. So even if you do have a lot of paint chips recovered from clothing, there's such diversity to the market, and these are the reasons why. And there has been several published articles, mostly were in the 70s, but there has been some since. But since the automobile industry painting and coatings continues to evolve, it is necessary to reassess the distinctiveness of automotive paints collected in the United States in order to determine their evidential value and the significance of any class associations in automotive paint evidence. So here's a typical report statement that we put in, and I know in this symposium we have focused quite a bit on report wording. A 6-layer red paint chip recovered from the victim's shirt is similar in color, layer sequence, paint type, and composition as the known red paint from the suspect's vehicle. It is our opinion that this paint chip could have come from the suspect's vehicle. What does this mean? It could have come from the suspect's vehicle. What is the significance of this statement? Is a 6-layer paint chip more common than a 10-layer paint chip? How common is a 6-layer paint chip? How common is red paint? And that's what this is going to show you. And what is the different discriminating value of the different paint types and color of the different vehicles? And I must stress that this study is not to apply statistics to paint evidence, but it is to support the importance of technical knowledge, analytical thinking, and common sense. The purpose of our study is twofold. It is an attempt to determine the degree of discrimination of automotive paint samples from a random population based on physical and microscopical examination, as well as instrumental analysis. as well as to address the frequency of occurrence of a paint sample based on color, effect finish, and layer sequence. And as Dr. Goodpaster talked about, that is class discrimination of the different analytical techniques as well as environmental issues in regards to how common different types of paint are. And we will also do pairwise comparisons to determine the discriminating value. And the degree of discrimination of paint evidence in combination with the frequency of occurrence of a paint sample will establish the significance of a paint association. This was our method collection. We collected 1,168 automobile paint samples were collected from damaged areas of vehicles in the summer of 2007. And as you guys probably won't recall, but that was the summer that we had an extreme amount of rain, so there was often times that we were stuck in the rain collecting these paint samples. But we were fortunate that we had dedicated interns to do it. Of the 1,168 samples, 500 hood samples were analyzed, which was the most prominent collection area. We also did collect samples from the quarter panels as well as bumpers, but we wanted to be consistent and we felt it was important in regards to the possible difference in chemistry and layer sequence from the different vehicle parts. So we only focused on hoods, and we had 500 samples from hoods that we compared. The make, model, year, and VIN was recorded at the time of collection, and each sample was given a unique sample number. And then when we got back to the laboratory, we used VIN Assist to verify the recorded information. And this is a breakdown of where our samples were collected from. From Garland, Texas, which is just outside of Dallas, we collected 47 hood samples. And then from Temple, Texas, which is north of Austin, and Austin, Texas, we collected the remainder. We collected a small portion from a salvage yard, but the majority of our samples were collected from auction yards. So they were recently damaged vehicles. Here's the results of our collection. As you can see, the majority of our vehicles were in the late 1990s to all the way through to 2007, with the median year being 2000 and the most common year being 2002. So we did get a very good representative sample out there from all the different places we were at. And then this is the breakdown of the different type of manufacturers that the samples were collected from. The primary manufacturers were domestic manufacturers, with General Motors being the most dominant. And these were just, for General Motors, it also included Buick and Oldsmobile and the other companies that they own, and Chrysler and Dodge were combined together, and Ford was also included various manufacturers. So we needed to come up with an analytical scheme to determine how are we going to compare these 500 samples. We consider solubilities. We did solubility testing. We did both for acetone and diphenylamine. And some of the the previously published articles from the 70s, they actually had a lot of significance with solubilities in regards to discriminating. However, since the industry has evolved, we actually didn't have much discrimination at all with solubilities. That we had a few that reacted with diphenylamine, but it wasn't worth a whole lot of time. We also examined the layer system, which included the actual number of layers of the paint chip, and we did physical cross-sections for all 500 samples, as well as any effect finish that was present and the color. And then we also characterized these if they were your typical 4-layer system, or if it was 3 layers, and if it was a possible repaint. And then visual color, we broke it down into these categories. We broke it down into red, purple, black, metallic. And metallic was our group that we consider that had limited hue, but a large amount of decorative flake. So it included your silvers and your golds and your pewters, because those were very difficult on a very small sample to sometimes to distinguish. Was it pewter, was it gold, or was it silver? And so we just kind of lumped all of those together and called them metallic. And then we had white, yellow, and then blue-green. And then what we did here is that we did do a pairwise comparison to show, just within these groups, and then if there was any possibility that they might fall within another group, we just put them in the other group as well and did a comparison. And then the samples that we couldn't distinguish based on physical characteristics, we further tested using the Fourier transform infrared spectroscopy. And then we determined the primary binder types, and we did spectral comparison. And then of the samples that we weren't able to distinguish based on FTIR, we followed up and did pyrolysis GC mass spec. And then we just did the pyrolysis comparison. This is the breakdown of our physical characteristics of the samples that we collected. As you can see, the metallics was the most dominant group, followed closely behind by the whites. We did have a good representation of red and purple and blue and green, as well as black. And as you can see, there was only a few yellow cars. So right here, we could start assessing as to how common different colors are. And of course, if you had a yellow paint chip, is there more significance to a yellow paint chip versus a white paint chip? Yes, there is. This chart displays the overall clear coat population, and as you can see, the majority of our samples had a clear coat present. 93% of our samples had a clear coat present, with only a small percentage remaining that did not have a clear coat present. This chart displays the clear coat per color group. And as you can see, the white group was the group that did not have a clear coat, the largest population of that clear coat population in regards that did not have one. Then this was our chart that displayed the effect finish. And as you can see, about 67% of our samples had an effect finish, and that was a decorative flake. And this chart reflects the population of the effect finish. And obviously, the metallic section had 100% of it was effect finish. And then the white population, though, however, you can see only a small percentage had an effect finish present. And this would include, it could include metallic as well as pearlescent. And then black, the majority of it did have a effect finish as well. And same with the red and purple and blue and green. This chart displays how common the different layer sequences are. As you can see, the 4-layer system was the most dominant layer system within our study, followed behind by the 5-layer, 6-layer, and 3-layer. But as you can see, the difference between the 4-layer substantially is different than the 5-layer. There's a big difference between the number there. Here's some interesting things that we saw. So we did a physical cross-section of all the different paint chips that we collected. And so as we were doing this, we started observing different characteristics that were like, this is interesting. What does this mean? What can it be? Can it go back to a specific manufacturer, possibly to a specific plant? Is this something that could help people if they saw this to start thinking a certain manufacturer? This was our first observation. This was, as you can see, there's a very thin black layer between your 2 primers, where my pointer is showing. It was extremely thin and it was elastic. So whenever I tried to initially scrape it, I had a lot of difficulty because of how thin it was, and then it was rubber-like. And so I ultimately ended up trying to rub it off with a wooden stick and got a sample from there. And we talked with some folks with PDQ, and they thought potentially that it could be an anti-chip layer. And this was the spectra that it produced. And they thought it could be an anti-chip layer due to the fact that it was resistant, and that if the rock hit the vehicle, that it wouldn't penetrate to the E-coat. And we primarily saw that in Toyota and Lexus. And then we also did have one sample that was a Mazda and one sample that was a Mercedes, but it was primarily Toyota and Lexus that we saw that in. And that we actually had 14 samples, and 12 of the 14 were representing Toyota or Lexus. The next observation that we saw was this extremely thick gray primer. We had 13 samples, and it was between 110 to 150 micrometers in diameter. We typically saw it in Dodge and Chrysler vehicles. Here's an example of what it looked like. And you can see the thick gray sample as to how large it is in comparison to the other primer. And the gentleman here from BASF, when I spoke with him a little bit more about it, he thought that this was potentially a powder primer. And then we actually, this is an example of the spectra that these had, and it typed out as a terephthalic alkyd with epoxy. And I know that's what some folks say could possibly be a powder primer, but then the BASF gentleman also stated that people are starting to go away from powder applications because of the high heat that it takes to bake it out. But we did see this, like I said, quite a bit in Dodge and Chrysler vehicles. Although we also did see it in one Honda vehicle as well. Something else that was interesting that we saw was color-coded primers. Here's an example of a color-coded primer that this is actually the primer layer. And we saw those typically in white cars as well as red vehicles, and all different manufacturers were using it, but it was the trend was the vehicle color that we could see. It was either white vehicles or red vehicles we did see that in. And we actually had 106 samples with a color-coded primer from various manufacturers. The next thing, and most of you guys have seen this before, is the bubblegum primer. Here's an example of it that we have a bevel cut as well as a physical cross-section of it. It was traced back to a Chevrolet Cobalt, and we had 3 samples that had this bubblegum primer, and they were 2006 and 2007 that were manufactured at the Lordstown, Ohio plant. However, we also had 3 samples from 2005 to 2006 that were Chevy Cobalts as well that did not have it. But it looked pretty. The next thing that we looked at that we saw was that there is tinted clear coats out there. Here's an example of a tinted clear coat that you could see is this like a strawberry red color. We primarily saw these in Ford vehicles, but after talking with Scott Ryland, he said that Honda is using the clear coat as well, the tinted clear coats. And we also did see it in Nissan, Dodge, Chrysler, and GMC. The primary color that this was with red. And then we also saw the modeled primer layers. We saw that in 29 samples. And as you can see, that was something else the BASF gentleman was speaking in regards to the wet-on-wet application. And that's the modeled primer. And we did see that from 29 samples, and 16 of them were Ford. Then we moved on to the IR, and these were our most common binders that we saw for the OT2 layer, the clear layer. We saw acrylic melamine, acrylic urethane, and then a combination of the acrylic melamine and urethane. And I was talking with a BASF gentleman in regards to this as well, and he was saying that your typical urethane you're unable to cure with melamine because they have such drastically different temperatures, so they try to modify the the urethane so that they are more compatible for curing. And here's an example of a spectra that we saw. And as you can see in the 1550 to about the 1460 area over here, that there's just a lot of stuff going on. So the conversation that I had with Scott Ryland and Ed Suzuki, because they are much, much smarter than I am, that it was just whether or not that could be a carbamate or not. And it was more or less like we saw this typically with General Motors, but however, we did also see it with Isuzu. And then for our OU1, of course, we saw the isophthalic alkyd or polyester was probably our most common OU1 surface primer. But we did see some combination of the isophthalic and orthophthalic alkyd, as well as epoxy and terephthalic alkyd that I showed you in regards to that very thick gray primer layer. Our OU2 layer is that we primarily saw it with epoxy with clay. However, we also did see a just straight epoxy layer. Okay, back to our comparison process. So our physical characteristics, which included the color, the layer system, as well as solubilities, we were able to eliminate 76% of our samples based on this stage alone. And then the ones we couldn't compare, we took on to FTIR. And from there, we were able to eliminate 18.2% of our samples. And I need to note that of the FTIR samples, that the majority of were 4-layer paint systems, and we did have a couple 5-layer. So, but we didn't sample anything that were 6, 7, 8, 9 layers, because we were able to tell them all apart based on the layer system. And then subsequently, the pyrolysis GC mass spec, we were able to eliminate 1.4% of the total samples that were processed. And we started off with 500 samples. We were able to eliminate 382 of the samples based on the physical characteristics. Again, that's the majority of our population. That left us with 118 samples. The 118 samples we processed on the IR, and we were able to eliminate 91 of the 118 samples based on FTIR. That left us with 27 samples that we ran on the pyrolysis GC mass spec. We were able to eliminate 7 of the samples based on pyrolysis GC mass spec comparison. That left us with 20 samples that we were unable to discriminate. And here's the breakdown of our actual samples that we were unable to discriminate. And the one that is highlighted in red was actually a blind control. We weren't able to eliminate it based on IR and pyrolysis GC mass spec, but when we were doing a check on our database and double checking the VINs to verify that no 2 vehicles were in there twice, this one was actually in there twice, that one person wrote down the VIN number, however, one person wrote down a lot number, and we were able to kick it out just because it was from the same vehicle. But then we were like, well, we got it right. And so then as far as the other ones, you could see we had one pair that was red-purple, and then one pair that was blue-green. And then we had 4 pairs that were white, and then we had 2 sets of metallics that we couldn't tell apart. And the E represents that it had some sort of effect finish. And these were all 4-layer, your typical E-coat, surface primer, finish layer, and then top coat. So these are all 4-layer paint chips that we couldn't tell apart. So we were able to tell apart the 3-layer paint chips, the 5 layers, the 6 layers, 7 layers. And then you could also see that most of them were either the same vehicle manufactured at the same plant, and then some of them are even the same year. But there is one here with the the blue-green, that one was produced in Missouri and the other one was produced in Michigan. And at first we were a little concerned as to why is it that we can't distinguish these 2 apart. And then again, talking with the gentleman from BASF, those were the ones that had that possible primer, powder primer, and he said that everybody basically purchases their powder primer application from the same company, so it doesn't have that discriminating value to it. So in conclusion, we had 500 hood samples, which ultimately resulted in 124,750 total possible pairs. We had 20 samples, or 14 pairs, that we were unable to discriminate. This resulted in a 0.01% of pairs not being able to be discriminated. Therefore, 99.99% of all total pairs were discriminated. Our further analysis will include SEM EDS on the samples that we could not discriminate, as well as X-ray diffraction and X-ray fluorescent, and possibly working with West Virginia University on Raman spectroscopy. And then we would also like to do a universal system study to see the similarity of chemistry layer systems from one area of a vehicle to another. Here's a list of selected references that we used in this study. And as you can see, there are quite a few references for paint analysis. And for acknowledgements, we would like to thank the DPS management staff for their support and funding, Rebecca Vasquez, Adriana Perez, Delisa Downey, and John Wachowski for help in sample collection, and Ivan Wilson and Melissa Valdez for help in sample analysis and data review. Are there any questions? All right, thank you.
I have a question for you. This is very interesting, the work that you have doing. How do you think this will be incorporated in your laboratory to change the way of wording and association on paints?
I don't know as far as our laboratory system how well they'll be able to apply this in regards to changing into various steps, but I know Chris Bomarito's talk that he gave as far as an association, a second association versus third association. I think this would be helpful to show that these statistics show that a yellow paint chip isn't as common as a metallic paint chip, or that a 6-layer is less common than a 4-layer. So I think it could help in that way. Thank you.